This is a rhombus, and as you know, a rhombus is a parallelogram where all four sides are of equal length. We're here to prove that the area of a rhombus can be given by half the product of the diagonals. The formula looks like this: area equals x times y divided by 2, where one of the diagonals is x and the other diagonal is y. And I'm going to use our knowledge of triangles and parallelograms to prove why this must be the area of the rhombus. Now let's begin proving this by clearing the diagonals and starting from scratch. First thing I'm going to do is draw a diagonal from bottom left to top right, and we're going to call that diagonal x. And you can clearly see that the result is two triangles. Now let's examine the edges of these triangles one at a time. Starting with the top triangle, we can see that the sides are A, and the diagonal x. Now looking at the bottom triangle, we can see that the edges of that triangle are A, and the diagonal x. Clearly, the two triangles have the same three sides, and because they share those same three sides, they must be congruent. In other words, they are exactly the same size. Next, we're going to add the other diagonal. Clearly, the diagonals intersect, and we're going to exploit two properties of intersecting diagonals. One property which applies to all parallelograms, and the other property which specifically applies to rhombuses. The first property that applies to all parallelogram diagonals is that parallelogram diagonals bisect each other. What that means is that the y diagonal passes through the midpoint of the x diagonal, so that either side of the diagonal you get two equivalent lengths of x over 2. Similarly, the x diagonal passes through the midpoint of the y diagonal, resulting in equal lengths of y over 2 either side of the x diagonal. By the way, if you want to know more about why parallelogram diagonals bisect each other, you can check out my previous video where I prove why parallelogram diagonals bisect each other. I've linked to the video in the description and in the comment section. Now the second property that we can exploit is one that is specific to the diagonals in a rhombus, and that is that rhombus diagonals intersect at 90 degrees. And that actually means that all of the angles around the intersect are 90-degree angles. Again, if you're not sure exactly why rhombus diagonals intersect at 90 degrees and you'd like to know more, check out another one of my previous videos where I prove why this must be true. Links in the description and comment section. And now, with this setup, we can show exactly why the area of a rhombus is given by x times y over 2. Now, looking at the two triangles, you can see that the sum of the area of these two triangles must be equal to the area of the rhombus. So we should be able to get this area by finding the area of one of the triangles and doubling the result, because remember, these two triangles are identical. Now we know that the area of a triangle is given by the formula half base times height. If we look at the top triangle, we can see that its base is just the entirety of the x diagonal, which means that we can rewrite half base times height as half the base, well, the base is x times the height. But what is the height of the triangle? The basic definition for the height of a triangle is a line that travels from the vertex of the triangle that is perpendicular to the base. A line is perpendicular to the base when the angle between that line and the base is 90 degrees. Now, because the line y over 2 begins at the vertex and is perpendicular to the base of the triangle, the height of the triangle must be the line y over 2, and so we can rewrite the equation for the area of the triangle as 1 over 2x times the height. Well, the height is y over 2, so that's 1 over 2x times y over 2. We can simplify this by multiplying the denominators and the numerators, and that will give us that half base times height, which is the area of one triangle, is equal to x times y over 4. We can get the entire area of the rhombus by simply multiplying both sides of this equation by 2, and that gives us that the area of the two triangles is equal to x times y over 4 multiplied by 2, and that simplifies to x times y over 2, which must be the area of the rhombus, which is what we were trying to prove in the first place. And so the proof is finished The area of a rhombus is x times y over 2, where x and y are its diagonals. That's it for now. Thanks for watching.